Hello everyone again and welcome. So today we will be continuing with how to import, the files into R, whether they are CSV, whether they are like text files. So we will look at, yesterday we just looked at this section where we could just take the whole file location and bring it in here, and then so that we can read that file. This is a little bit, copying all of this in here might not be the best way. So one thing I'm going to do today, I'm going to show us another way how we can do this um, by using what we call like changing the work directory. Remember, if I type yesterday, I did mention if I type get wd, which is like the work directory that we are normally supposed to have, is giving us something different. It's not giving us the location where we are having our data stored. Our data is on the desktop. If we can see from here, you see it says desktop, but yeah, we are having like the current working directory to be like documents, but it says the work directory I'm using is supposed to be on the desktop, and we have reset summer, and then we have start and prop, and then we have their notes in there. So that is what we are going to be looking at. How do we set this current working directory every time we just want to read data from there rather than copying the whole, that location. So one thing we have to do is you can do set wd, which is like set the working directory. I'm going to do column, and then I'm going to copy where I have this right up to where I have my notes, because there I know I can have different data sets. So I'm going to do this, paste it in here. One thing you have to know is once you set this work directory, every time you need to come run this, because it will always change over time. So you see that my work directory has been changed to where my data set is. So if I want to read that data as we did yesterday, I can just do, for example, data, and then I'll do read. Let me read that philosophy data. So I'm going to do read, and then I'll simply just come in here, and I can just take that philosophy. I want to read the CSV version, not the Excel. I'll just copy this, paste here. Remember the file extension is .csv, and then I'm going to run it. So you see that when I do data here, or view, we can see that here I'm having that my data set. So most of the time I advise that you can change that working directory to where you keep your data set, so that every time it is easier for you to read that data rather than copying the whole of this, this long extension. And but if you want to do that, that's still fine. So next thing we can do is we have like another data. How do we read data which is in form of like a text file, like extension of txt? So I will do, let me say text underscore data. I have another data set. I'm going to be pasting that data to. I'm going to, instead of doing which is a text file, I'm going to do dot table. Here I'm going to pass in that table. That data set is still in there. Let me just try to look at the extension of that data so that all of us will see what is in there. I'll just bring it up here. So the data is in here. I go to notes. I want to read a text file. Yeah, let me just read this one. It says example 02-14, which is a text file. Let's get back here. I'll do example 02-14.txt. Now I want us to see something. I'll run this and then you see what I'm talking. So if I call this, you see, you have to be very careful, especially when you have such files. If I call this, you see here that it's giving me some added column names, which is like v1, v2, v3. This happens in R if you are reading a data that doesn't have column names. But with the text files, most of the times you have to pass in these this header, which says you want the header to be true, meaning that you want the columns that comes with that data, not adding this extra v1, v2, and so on. So if I do that and run that data, you will see that we are having the column names that originally comes with the data. Another thing we can have, like let's say for example, you have a data set to read, and let me say I want to try to rename columns in the data set. Let's say there are different ways you can do that. Let me say data underscore and name, and then I want to read another data set. That data set will be the CSV file read.csv. That data name I think is 3. Let me look for it. I can look for that data set with yeah, tree growth. Tree growth, we can check it is a comma separated file, so I'll just do tree growth. It is .csv, and then if I do data underscore name, we see that we are having funny column names like x1, x2, x4, and so on. So let's say if I know these column names, let's say I do not want the x and so on, I can try to rename the column names. So one thing you can do with renaming those column names in R, you can just do you can just call. I'll go with the easiest format. You can do call names, passing the column. So you pass in the name of that data, which is what data underscore name, and then you are assigning it. So what I want to do is I want to change those column names. How many column names do we have? We have like 5. We have like 9. So I'll just give them different column names. Let me say I'll just call them column 1, and then I have another name. I'll call it column 2. Then I can have column 3. No, this one is going up. Sure, supposed to be in here. I can do column 3, column 4. Let's just try to read this better. I'm sure it might not work because of the fact that we haven't renamed all those columns. Let me see. Yeah, think if I do just rename the first 4 columns and see what we get. So let's go back to that data. It's a little bit, you see that it has renamed these first 4 columns and then this other column that it doesn't have names to it is giving it what missing columns, which means any. So meaning that once you want to rename the columns in the data set, make sure that you rename all the columns. Do not just take the first, because it's by default it is saying that you only rename the first 4 columns, which makes sense. So the other columns, which is the last 5, is not renamed. So I can do another column 5. I can do column 6. I can do column 7. I think there were initially 9 columns. I can do column 8, and I can do column 9. Column 9. Then let's run these, and then instead of just going through this way, I'll just do the view format we normally have. I'll just do view of our data underscore names, and let's see what we get. So it opens on this panel. Now you see we are seeing that we have renamed the columns. Initially we had x1, x2 right up to x5, and then we have y1 to y4. So we have renamed these column names to something else. So most of the times you might have a data set that data frame where these column names are not really what you want, and then you want to rename them to something that it looks similar to the data set you collected, especially if you're doing some research. So be very, very careful with every data set you're working on, because data cleaning is the highest thing you do, especially when you're building whether they are predictive models, whether you are doing some dashboard, data cleaning is always the best thing, because if you do not clean that data set very well, then definitely whatever analysis you're doing wouldn't make any sense. Now, there's something last time when I was teaching I didn't mention, which is like what we call a factor in R. Now, if we let I read this text data that we have here, let me see something. If I needed to look at the want to look at the data types in that data text data, if I run this down here, we will be seeing that pipes is like an integer, but those integers are just like 1, 2, 3. Most of the times we can term that kind of data categorical. Like we see this plant here. With plant, we can see that plant has 1, 2. So if I need to do a box plot, which this plant category, we have just two categories, which is 1 and 2. But you see that it's showing that it's an integer. Let's say I wanted to do some analysis. Let me say I wanted to see the box plot of those plants based on the various temperatures. I know this temperature column. If I do like a box plot, because this one is showing integer, but it's normally supposed to be something which is a category, which is like just 1 and 2. If I do let me say I want to do ggplot. Let me call of I want a box plot using the ggplot library. Normally you're going to run this, and then I'm going to do ggplot pass in. I need that data, which is what text data. Normally I pass my AES. I want to do a box plot of what, of plant, which is the categorical, versus what, temperature. Then remember, after this I'm going to do plus jump underscore what, I'm picking box plot. Let's see. You see that this box plot is looking funny. It is just showing that it's just like a single box plot, calculating the mean and so on, but it doesn't make any sense, because this plant here is supposed to be something which is categorical, because we are just supposed to have something like 1 and 2. So how do we handle such cases? How do we clean this data so that we can have a better analysis? So one thing we are going to do is like converting this plant into like a factor, which is going to just have like what, just 1 and 2, which is like so how do I do that? I'm going to just call data, and then data underscore no no, it was supposed to be it's text underscore data. What column do I want to change to a factor? I'm changing that plant column, assigning it, so I will just do factor. Or you can just do type factor, and then I pass in text, that text underscore data. Which column do I want? It's like you can also do like column rename this way if you want to. It works also in arrow. So I want that plant, and I run this. Let's see the data types, how that data is going to look like now before. So let's see. I run this now. Let's see. We see that plant is no longer the way it was like an integer. It's now saying that it is a factor, just with what, 2 levels, which is just like 1 and 2. So if I go back and run, I don't want it, so I can just copy this box plot down here and cut everything. Since I've like arranged my data, it looks nice. So if I plot this, you see that this box plot now is different, which makes sense because this plant has just 2 levels, which is like just 1 and 2, which makes a lot of sense. Even this pipe is supposed to be just 2 levels, meaning that if I also want to change that pipe to something else, I can do that and then copy. I can just do this copy paste down here. I want to change this pipe, and then also I come in here, change pipe. So you have to be very careful, especially when you are working as a data analyst, because you have to ask yourself, is this analysis I'm doing, does it make any sense? You see here, this one is showing that there are like 48 levels. Might make sense, might not make sense, but 48 levels, if you were trying to compare like this one of the plant, it makes sense. If I was trying to maybe like look at the mean for these two groups, Are those means the same, especially if you're trying to do some hypothesis testing? From here, we can see that the means are a little bit same, and this distribution seems to be symmetrical. And then we can carry out different, statistical tests like the two sample t-test, which you are comparing two means. We are going to see that as we move ahead in this lesson. That was it for this video today. The next video, we are going to be looking at how we can calculate contingency tables, two-way, three-way, and so on, especially if we are going to be, dealing with categorical data a lot. Thank you so much, and keep following for more.